With your query window up, let's create a new table. And let's call this Human Resources Room Chart. And what this is this will keep track of all of our guest meeting rooms and their sizes and everything. But we're going to start off with a very simple design. We're going to say r_id for room ID, which we'll set as an int. And we will say not null. And then we're going to go to the room code, which we'll set as a char 3, and that can be null, at least in the short term. Create this table. Now notice it has 2 fields, but currently it has no records. Okay, if I were to insert one record, how much room would it take up? Let's insert one record right now. Insert into Human Resources.RoomChart the following values. Room number 1 will be the RLT room, and I better put single quotes around that. And there we go. Okay, how much room does an int take up, and how much room does a char 3 take up? Well, let's go ahead and look at the design of the table. Let's expand this. And let's go to Human Resources, Room Chart, and let's click on Design. If you were on SQL 2005, you would say Modify. Okay, our first field is an integer, which is taking up exactly 4 bytes. Our second field is a char 3, which is taking up exactly 3 bytes. Therefore, this record is taking up 7 bytes. If we were to insert another record for room 2, it would take up an additional 7 bytes. Let's say room 2 is QXT. And then we'll select. We know the data payload for row 1 is 7 bytes, and we know the data payload row 2 is 7 bytes, therefore it's taking up 14 bytes. So what are all the calculations that go into row sizes and data types to be able to calculate the expected consumption based on your incoming data? That's what this lab is all about. So we've left off with a table design that takes up 4 bytes for the first field and 3 bytes for the second field for a total data payload of 7 bytes. And then we put 2 rows in it and we're consuming a data payload of a total of 14 bytes. Well, what if we added 2 more records with a slight variation? Now we're going to use a row constructor here so we can do it with one insert statement. We're going to insert row 3, which is the TQW code, and row 4, which is the XW, only 2 letters long. Let's execute this and look at this data. Now, this takes up 4 bytes, this takes up 3. This is 4 bytes, this is 3, this is 4 bytes, this is 3. This takes up 4 bytes. This also takes up 3, because a char 3 takes up 3 bytes whether you use it or not. It is not designed for a variable length of characters, so if you do not use it, the data is still used. So what is our total calculation? Well, if it's taking up 7 bytes per row, and we have 4 rows, that's 28 bytes, except that's just calculating the data portion. This row has a header, which you can kind of see here as its representation. The header is a positioning header that keeps track of where it is in the table and what fields it has. That header takes up 4 bytes. So this first row is taking up a 4-byte header and 7 bytes of data. So the first row is taking up 11 bytes. The second row is taking up 11 bytes. These 4 rows, with the calculation given so far, is taking up a total of 44 bytes. Calculating the data row usage of fixed length data is pretty straightforward. We also have the ability to add variable length data. Let's go back to the design of our table, and we're going to add a new field. We're going to have a room name, r_name. And we're going to say some rooms are really long names and some rooms have very short names, just like you've known people with long last names and long first names and short last names and so forth. So we're going to say that room names can go up to 25 letters in length. So I'll say n var char 25. And it's allowed to be null. So let me save this, rerun the query, and notice currently we don't have any room names. Well, let's go ahead and start adding some names in by saying edit top rows. And the name of the first room, the RLT room, is the Renault Langford Tribute Room. So let's start entering that. And let's widen it so we can see. That's taking exactly 25 characters of the 25 possible. So that one maxed out the capabilities of the field. Second one, the QXT, is the Quinault Experience. The next one, TQW, is Tranquil West, with no hyphen. And the fourth one, XW, is Xavier West. Okay, let's close out of here. And let's look at our data. Let's delve into the data types and their consumption patterns before asking you how much each of the rows of the last example is actually consuming. Now, let's start off with the fixed length data types, like an integer. Regardless of what you put inside that field for any given row of an integer, it's always going to take up 4 bytes. A char3 is another fixed length data field. A char3 will always take up 3 bytes. How about a char4? Well, since it's 1 byte per character, that's going to take up 4 bytes. Now, there's a more advanced character set that will support not only the types of characters you see on your keyboard, but also international characters like German umlauts, Japanese kanji characters, Chinese writing, all kinds of stuff that is considered international. That's known as Unicode. N is the symbol for Unicode in SQL, so if you get an N char, that means you're going to take up 2 bytes for every Unicode character. So if you have an N char of 3, that consumes 6 bytes. Therefore, a fixed length N char 4, since it's 2 bytes per character, that's going to take up 8 bytes. Now, let's go back to the regular characters that take up 1 byte per character. And let's give it a varying length, like a varchar 10. Perhaps some words are going to be 10 letters long and some are going to be 2 letters long. How much does a varchar 10 consume? Well, it takes up 2 bytes to have a variable length, and then it takes 1 byte per character. So, a varchar 10 could take up to 12 bytes. Now, if you only put 2 characters in it, it would take 4 bytes. So basically, a varchar consumes 2 bytes plus 1 byte per character up to the maximum that you can fill. Therefore, a varchar 15, that could take up to 17 bytes. If we take a varchar 8 and only partially fill it with 2 letters like the word yo, it takes up 4 bytes of space. Why? Well, yo is actually only 2 bytes worth of data payload, but with variable length data, we have to dedicate 2 bytes for every row for every variable length data type into what's known as a variable block. A variable block is necessary because it's impossible to predict the beginning and the ending, similar to what you see with the 2 single quotes here. Isn't that taking up 2 bytes just to mark the beginning and the ending and to make it really clear? Quotes don't really take up any space. It's the beginning and ending marker inside of SQL that takes up the space. Yo would take up 2 bytes of data, and 2 bytes would be dedicated to the variable block. So young is 5 bytes of variable length data, and, again, just 2 bytes dedicated to the variable block. The word youngest is taking up the full 8 bytes of variable length characters, and 2 bytes are dedicated to the variable length block. Now, a common question I get is, What if I declare a varchar 10 and I put 2 letters in there like RL? And I declare a varchar 15 and I put in 2 letters, RL. Is there a difference? No. In both situations, those would consume exactly 4 bytes. Okay? If it costs 2 bytes just to own a variable length character, how about a variable length of Unicode characters? Now, how about an nvarchar 10? We know that could take up to 20 bytes worth of Unicode characters. Since 2 bytes are dedicated to the variable block, and a nvarchar 10 can take up to 20 bytes of payload data, the total consumption possibility for an nvarchar 10 is 22 bytes. If you put 6 characters in an nvarchar 10, it would take up 12 bytes for the characters, and another 2 bytes for the variable length set, so that would consume a total of 14 bytes. Let's go back to our room chart table and look at the design and the population and estimate the consumption. Now, of our 3 fields, the first 2 are an int and a char 3, which are fixed length fields, and the last field, the rname, is a variable length field. Well, we know exactly what the first 2 fields are going to consume before we even look at the data. The third field, we're going to have to look at the data to know what it consumes. Let's take a look at the first row. Okay, we know for sure that the header in every row takes up 4 bytes, so we're using 4 bytes for the header. Our fixed length data consists of the row ID and the row code. 4 bytes for the ID because it's an integer, 3 bytes for the code because it's a char 3, so our fixed length data is consuming 7 bytes. How about our variable block? All we have to do here is count the number of fields that contain a variable length data type. Currently, there's only 1, so we only have 2 bytes for our variable block. Well, our variable block is going to consume 2 bytes. We also have exactly 25 letters in Langsford Tribute. Now, since that's Unicode character, those 25 characters will take up 50 bytes. So we're going to add 4 bytes to 7 to 4 to 50. Two important rules about the variable block we need to know before we do any more data row calculations. Number 1, the creation of a variable block takes 2 bytes. Number 2, it's going to take up 2 additional bytes for each variable length data type in your table design. Let's use an example. This is the design view of the employee table. You know for sure there is a variable block because you have 1 or more variable data types, namely last name and first name. They are both variable data types. So, a variable block with 2 bytes was created. 2 more bytes were added to the variable block because of last name, and 2 more bytes were added because of first name. Therefore, the employee table is taking up 6 bytes in a variable block for every record added. Let's take a peek at the customer table's design. 5 fields total. Looks like 4 of the fields are variable length data types. So, we've got to set up a variable block. That costs 2 bytes. Then, we have to spend 2 more bytes on every single piece of variable length data. We've got 4 of them. That's 8 more bytes. Therefore, on each record of the customer table, the variable block will take up a total of 10 bytes. Let's repeat this process for row 2. Row 2's header takes up 4 bytes. The fixed length data consists of an int taking up 4 and a char taking up 3. So the fixed data takes up 7 bytes. The variable block is taking the number of fields that have variable length data, and there's only 1 of them, and multiplying that by 2. Finally, the Quinault experience, these are Unicode characters, so that's taking up 38 bytes. With your header taking up 4 bytes, your fixed data payload taking up 7 bytes, your variable block taking up 4 bytes, and the amount of variable data in your second row taking up 38 bytes, total memory space used for row 2 is 53 bytes. Lab 3.1, Skill Check 1. Calculate the space consumption of rows 3 and 4 according to the table design you see here. That does it for Lab 3.1 on data row space usage. Next item, Lab 3.2, null data.